The Sun is about 148 million kilometers away from us, and its diameter is roughly 1.39 million kilometers. It's so huge that it could hold about 1 million Earths inside it. For thousands of years, people have been studying it with great interest. However, we still know very little about it. But humans are taking active steps. Advanced telescopes are being built on Earth, and some have already been sent into space to help us unlock the biggest mysteries of the Sun. The greatest inventions of mankind are now presenting us with amazing images of our star, showing us what it looks like in ways we've never seen before. The Sun, located at the center of the solar system, is nearly a perfect sphere made up of hot, sizzling plasma, giving off intense radiation, heat, and light. The Earth is actually within the vast atmosphere of the Sun. This complex space environment sometimes disrupts space technology, communication and navigation systems, as well as the power supply. If we could predict the severe space weather from the Sun in the future, it would help us get ready for solar storms. But we need to get closer to it to understand it better. Nowadays, telescopes on Earth are taking extremely detailed images of the Sun. The Daniel K. Inouye Solar Telescope, which is located on the top of a mountain on the island of Maui in Hawaii, is the world's largest solar telescope for observing sunspots. On January 30th, 2020, this telescope took some high-resolution images of the Sun, showing the patterns of the surging and churning plasma covering its surface. The hot solar plasma rises in the bright centers of these cells, and then cools down in the darker lanes beneath the surface. This process is called convection. But the Daniel K. Inouye Solar Telescope was just getting started back then. An image taken on December 11, 2020, was the most detailed photo of a sunspot that humans had ever seen. It showed a magnetic structure of the sunspot that was up to 20 kilometers long. The sunspot has a blazing hot core with a diameter of about 16,000 kilometers, which is big enough to hold the Earth. This dark area is a gathering place for magnetic fields, blocking the heat from the inside of the Sun from reaching its surface. Even though the temperature of this dark area of the sunspot is lower than the bright parts, it's still over 4,000 degrees Celsius. People also discovered that from these dark areas, there are strands of hot ionized gas stretching out for kilometers. What was previously thought to be empty space. These amazing images showed that each strand of gas has a temperature as high as 1 million degrees Celsius. The most incredible thing is that the Daniel K. Inouye Solar Telescope took this image of the sunspot even before its facilities were completed. That means, with its advanced optical equipment and 4-meter primary mirror, this telescope will be able to take even more amazing images in the future. Currently, these are the best images of the Sun taken from Earth. But now, there are some telescopes in space that can take even better pictures. The Solar Dynamics Observatory, SDO, of NASA, was launched into a geosynchronous orbit above the Earth on February 11, 2010. It's a vehicle-sized device with 3 main instruments. The Atmospheric Imaging Assembly, which is a set of 4 detectors designed to take pictures of the Sun's surface and atmosphere. The Extreme Ultraviolet Variability Experiment, which is used to measure the Sun's ultraviolet radiation output, and the Helioseismic and Magnetic Imager, which can map the Sun's magnetic field and observe what's beneath the opaque surface of the Sun by using a technique called helioseismology. That is, studying it by detecting the vibrations on the Sun's surface. It has been observing the Sun for over 10 years. Through time-lapse photography, you can see the outer corona of the Sun in extreme ultraviolet wavelengths, and the rise and fall of the solar activity cycle. The Sun goes through an activity cycle every 11 years. During this period, its size expands and contracts. When that happens, the north and south poles of the Sun switch places. For centuries, people have observed this cycle through changes in the Sun's appearance and phenomena like the northern lights on Earth. During this 11-year cycle, the activities on the Sun can be seen fluctuating in sync. Solar flares, coronal mass ejections, sunspots, solar loops, and even the level of solar radiation are all related to this 11-year cycle. From Earth, the Sun looks like a fairly stable celestial body, but when we get closer to it, we'll find that the Sun is actually very unstable. Solar flares occasionally erupt from its surface, shooting out a large mass of high-energy, strongly magnetic plasma into space. This is called a coronal mass ejection. On July 19, 2012, the Ultra-High Definition Telescope on NASA's Solar Dynamics Observatory captured amazing images of a solar flare erupting from the Sun for several hours. The huge arcs were much larger than the Earth, compressing million-degree plasma. These plasmas started to cool down and fall back to the surface in an electromagnetic storm formed by ionization. The changing plasma was strongly influenced by the Sun's magnetic field. When the plasma fell, it condensed along the long, twisted magnetic field lines near the surface, forming huge flowing arcs as high as 5 Earths. On April 17, 2016, the Solar Orbiter captured amazing images of medium-sized solar flares erupting from the Sun's surface. These astonishing images might help us understand what causes these powerful radiation phenomena. Powerful flares are always being generated, but solar flares don't always have enough intensity to produce a large number of coronal mass ejections. In most cases, they just appear as bright spots on the Sun's surface. However, when plasma is ejected from the Sun, it's truly an amazing sight. The largest flares could cause power outages on a global scale. November 2020, the Earth almost got hit by a solar flare. But don't panic. This kind of activity doesn't happen all the time. And even if a flare occurs, it needs to happen at a very precise time to have an impact. Even though we have powerful telescopes in orbit, there are currently other spacecraft on their way to the Sun. By NASA and the European Space Agency, was launched in February 2020. It's one of the most complex scientific spacecraft so far. Its goal is to take the first pictures of the north and south poles of the Sun. This probe is equipped with 10 different instruments, including high-resolution telescopes and other measuring devices. Its mission is to get as close as about 42 million kilometers to the Sun, study this hot star in an inclined orbit, and directly observe the poles that humans have never seen before. The solar orbiter has to endure extreme temperature changes, from minus 184 degrees Celsius in space to about 482 degrees Celsius when it gets close to the Sun. So the instruments on the spacecraft are protected by a titanium alloy heat shield and coated with a calcium phosphate coating. However, the environment is so harsh that there isn't a camera on the spacecraft that directly faces the Sun. Even so, the solar orbiter has still taken some breathtaking pictures on its way to the Sun. On November 18, 2020, the heliospheric imager on the probe took images of Venus, Earth, and Mars. The new images, taken when it was just 77 million kilometers from the Sun's surface, are the clearest photos of the Sun ever taken. These images revealed a never-before-seen phenomenon: tiny solar flares all over the Sun's surface. They're only 1/1,000th the size of ordinary solar flares. These tiny flares are called campfires. It's not clear exactly what they are yet, but they might be tiny explosions or nanoflares. They might help heat the Sun's upper atmosphere. You might not know that the temperature on the Sun's surface is relatively low, only 5,500 degrees Celsius. But the temperature of its surrounding upper atmosphere is over 500,000 degrees Celsius. What's even more surprising is that scientists discovered 80 years ago that the temperature of the Sun's corona is 2.77 million degrees Celsius, higher than the Sun's surface. The hot corona makes the Sun's outer layer expand into a constantly flowing plasma called the solar wind. These solar winds extend beyond the orbits of the planets, forming a bubble around the entire solar system, which is called the heliosphere. However, how the Sun accelerates these solar winds and spreads them throughout the solar system is still an unsolved mystery. To solve this and other strange solar phenomena, NASA's $1.5 billion Parker Solar Probe was launched in June 2018. Its mission is to study the outer corona of the Sun. It will get extremely close to the Sun, as close as 6.4 million kilometers, which is 7 times closer than any other probe. You might be wondering, won't a probe that gets so close to the Sun be burned up? The Parker Solar Probe is designed to fly through the Sun's super-hot outer atmosphere. But to survive the high temperature and complete its 7-year mission, it needs to fly at an extremely high speed. So it will orbit Venus 7 times during one of its approaches to the Sun. The probe took an image of the plasma flow in the outer corona. The bright spot at the bottom of the photo is Mercury. By the end of its mission in 2025, the Parker Solar Probe will be flying around the Sun at a speed of 700,000 kilometers per hour when it's closest to the Sun. The front heat shield of the Parker Solar Probe will face heat and radiation as high as 1,377 degrees Celsius. But the instruments on the other side will stay close to room temperature. What do you think the Parker Solar Probe will discover? And what will the solar orbiter reveal when it completes its mission? By studying this star that coexists with us, we can not only learn more about other stars in the universe, but also might be able to predict the occurrence of solar storms. However, even up to now, we still know very little about the specific internal structure of the Sun.